So the second speaker today, the second talk, O2, Natural User Interfaces by Noah Orr and Dave Redder, Department of Computer Science, Ohio Northern University, and the presenter is Mr. Orr.
Hi, my name is Noah. I'm a sophomore at Ohio Northern University, and over the summer, ONU gave me the opportunity to work on a program called Natural User Interfaces. Natural user interfaces are systems that allow users to control electronic devices in a way that's more intuitive, natural, ergonomical, or ingrained than traditional systems. For example, mouse clicks are replaced by swiping motion of the hand, which is a gesture that people already make daily. The idea is that a person will be able to control his or her computer more easily because the way they give commands is more like the way they interact with the real world. So for my project, we studied two devices, the Microsoft Kinect 3D camera and the Emotive Epoch brain-machine interface. We started with the Kinect. The Microsoft Kinect includes several sensors. The main 3D camera consists of an infrared laser. It sends out a field of infrared points. The infrared camera can see these points and using an unknown method is able to calculate how far away each pixel in the image is from the camera. This information can be used directly, but the Kinect can also use it to pick out people in the image, and it can give you that data automatically. The Kinect also includes a color camera and a directional microphone array, which can be used for speech recognition. For our first Kinect project, we decided to start simple. After studying some example code using the Kinect, we decided that we should be capable of writing an application that uses skeletal information, so where the joints on your body are. We built an application that would measure the angle of a user's shoulders to determine their posture, whether they were falling to one side or another. The project was inspired by my neighbor's equine-assisted therapy riding program. Many of the riders have difficulty staying upright on the horse, and so this could be used to give feedback to instructors on the posture of riders while they're riding. So after that project, we decided we wanted to consume the raw depth data from the camera, so we made an application that would subtract the background from an image. The application ran very fast and smoothly. As you can see, the depth image didn't exactly match the color image. I believe this has to do with the position of a person. Like when they're closer to the camera, there's a difference in geometry from the color image to the depth image. And in any case, this can be fixed using a function that comes with the Microsoft Kinect SDK, mostly fixed. One of the greatest advantages of having a 3D camera is the ability to pick out multicolored objects. So that's really difficult for a camera to do. So I programmed the Kinect so that it would search for the single line of the depth information for things that are round. And so we placed cylinders and rectangles into the Kinect's view, and it was able to distinguish cylinders from squares, even though from a color camera standpoint, they were indistinguishable. I then programmed the Kinect to compare various 3D shapes, and by learning what the shape looked like and comparing it to the others, that's what this picture is of. The application works by picking a single starting point and then comparing it to every adjacent pixel. If the adjacent pixel is within a centimeter in depth or so of the first pixel, then that pixel is counted as part of the object as well. And so it maps out an entire object. As we ended the Kinect project, we decided to combine all the features of the Kinect into one application. The application uses skeletal data to target the user's right hand, which is used as a pointer. As you can see, there's a red square where my right hand is. When the user says Kinect target verbally, it's a speech recognition. The Kinect maps out the shape of the object, and it stores a color image. As the user moves their hand, that image follows them around on screen. So you can see that's actually a virtual image. It's of a shape, and the actual shape is sitting on the desk there. The Emotive Epoch headset is essentially a wearable EEG machine. It has 16 sensors that contact your scalp to read electrical signals. It can be trained to detect facial expressions, emotions, or conscious thoughts. It also includes a pair of gyroscopes that detect head motions, but we didn't use those in our project. The Epoch headset is fascinating to actually use. A new user must first train the system to recognize their brainwaves. They do that by associating different thoughts and feelings with the actions they want to occur. So, for example, to move a mouse upwards, the user could think about lifting things or flying. When they don't want to move the mouse, they have to think about something else. And it's actually really difficult. It's more difficult than you think to do. The amazing part of the Epoch, though, is you can interact with the world without moving a muscle. It's reading your brain waves. The headset proved much more difficult to program than the Kinect. The software for the headset handles all the work of decoding the brain signals, but actually telling the headset when to start training and what to do was more difficult. The only really successful application we made for the Emotive was a simple mouse emulator. So the user trains the headset for two actions, one to move the mouse up and one to move it down. And I was able to successfully control both actions, but there's also several second lag time with the system, and that was very frustrating. The Epoch helmet uses conductive felt pads to pick up brain waves from the user's head. Each pad has to be dipped in a saline solution and attached to the helmet before you use it. And then it has to be disassembled after use so the pads don't dry out. On my head, the pads were pretty uncomfortable after about 20 minutes. However, that said, the Epoch helmet is a very powerful tool because it allows programs and users insight into a very mysterious thing, the brain. Other tools such as mice, keyboards, buttons, levers, cameras, microphones, even that cool Nintendo Power Glove, they all rely on physical manipulation. The Epoch has the potential to allow our devices to learn what we want without us telling them in any way. So the Epoch can tell when your brain recognizes a pattern that you're thinking about. There are certain groups of neurons that fire. And so the Epoch can listen for those neurons, and you wouldn't have to learn any gestures or commands at all. But the system would already know what you're thinking. There'd be no training. So we combine these projects to create one very interesting project. The Kinect monitors your entire body, so any movements that you make change the input to the Kinect camera. The Emotive can read your thoughts without making any movements. The combined application uses the Kinect to pick out a single object, and once it's located, copy it onto the screen. This copy can be moved up and down using the Kinect headsets, like you're levitating this virtual object. It was a lot of fun. Many projects have been undertaken to study the usefulness of the Kinect and other natural user interfaces. Robotics is often a part of these studies because robotic systems are very complex and hard to control. However, a majority of the applications for the Kinect and other natural user interfaces will probably be more mundane. Both the Kinect and the Epoch helmet are off-the-shelf solutions for anyone who wants to experiment with natural user interfaces. Both utilize technologies that may soon enable more natural interaction between people and machines. Thank you for your time. Yeah.
Okay, so the neurons firing in your brain emit some kind of waves or something that are picked up by these sensors.
Mm-hmm.
How does that work?
Your brain waves will actually show up as electrical differences in electrical potential on your scalp. And so the Epoch monitors mostly their waves using concentration or sleeping. I don't remember what they're called exactly, but it can monitor those, and because it has 16 different sensors, it can map out different points on your brain where those waves are coming from. So when you are using a large part, when you're concentrating with certain parts of your brain, it can tell the difference between states.
So is it like a frequency of the brain waves, or is it like on and off? Is it binary? And what causes the brain waves? Are those like radio waves or like microwaves?
Your neurons firing. Your neurons, I'm not a neurosurgeon, so I do not know exactly, but your neurons create electrical signals, and it is the frequency of the waves, it is the amplitude of the waves. There are a lot of different things that it senses, but one of the best parts is I didn't have to know any of that, because the software that's written for the emotive headset already analyzes all of that information for you.
Just practically, you were saying programming. What language were you using? How hard was it to program the thing, the Kinect, the emotive, to do the different tasks you wanted?
The Kinect, we programmed both using C#, using Visual Studio 2010. The Kinect was pretty simple. There was one DLL, one linked library for it. There was a lot of example code available. The emotive, there was also code written in C#, but there wasn't as much example code, and the way that you communicate with the emotive is across a network. You can use your own computer, but you still communicate with it over a network. And it rejects commands if you give it commands that it doesn't understand. And it doesn't give good error messages.
Curious if you know of any other kind of interesting uses for the Kinect, because it's so cheap. It's a nice thing to have in the natural language interface community.
Yes.
Like I heard last week were the Black Hat and DEF CON conferences. I don't know if those are still going on, but you know, it's a bunch of malicious people in a room and kind of play jokes on each other. One of them had rigged up a Kinect to actually hack other people's machines as it detected people doing different gestures. As a laugh. Yeah, I'm curious if there are any other kind of interesting uses of that.
I saw a lot of different things done. I was very impressed. I think one of the craziest things I saw done was someone mounted it on the front of an electric skateboard, and they controlled the speed of their electric skateboard by moving their hands up and down. And they drove it in traffic, which I thought was pretty crazy. I think one of the coolest things I saw was not actually done with a Kinect, but a very similar 3D camera. It was only a camera. They built little models of Lego houses and cars, and when they would place them on the table, they had a projector above them that would project scenes based on location of different objects. So it's almost like a smart house kind of technology where you can keep track of objects in an environment, their exact 3D location.
Just real quickly, the emotive sounds really difficult because let's say I start thinking about what I'm going to have for lunch. So how do you channel someone's thoughts to just be directed towards, moving the mouse, up or down? I mean, how do you handle sort of all the noise?
It's difficult. Like I said, the Epoch does a lot of the analyzing for you. You just tell it when to train and when to stop and when to listen for those. However, there's a lot of false positives. Once you start talking and doing something else, it will start registering little jumps in the signal. It gives you an analog kind of feedback. The best thing I found was when I was giving my little video presentations of it, was that I would just keep talking while it was training, and I'd be concentrating on talking to people like I am now, and then when I stopped and I just kind of calmed down, then I would train it for levitating the virtual object, and there was a definite difference between when I'm concentrating on talking to people and just meditating. So yeah.
Just a quick one. How much does the Epoch cost?
Just the headset costs like $300, I think it was.
The headset's
Cheap.
with the SDK.
SDK.
The SDK and the headset it cost $3,500.
So,
And then an additional headset was another $500.
so the software.
The SDK was the expensive one. But that was